The Los Azines wind farm is located in the municipalities of Los Azines, Ibias de Hueros, and Carcedo de Burgos, southeast of the capital. The developer is the company Parque Eólico Los Azines, formed by two partners, Energías Renovables del Bierzo, ERBI, a company belonging to the Lamelas Viloria Group and dedicated to the development of renewable energy projects, and Cinia Renovables, a 100% owned company of Banco Sabadell, specializing in investments in renewable projects. The total power of the park is 27 megawatts, which includes 15 Vestas wind turbines with a unitary power of 1.8 MW. The estimated clean energy generation for this park is 103 gigawatt-hours per year. The connection to the electricity grid will be made by extending the Carcedo substation. To this end, a new 220 kilovolts position will be built with a 32/120ths of a kilovolt power transformer of 40 MVA and a control building with 30 kilovolt cells for the arrival of the wind turbine circuits. The medium voltage network, which will interconnect the wind turbines with each other and with the booster substation, is planned with the installation of more than 50 kilometers of medium voltage cable at 30 kilovolts. A fiber optic communications network of more than 16 kilometers will also be installed, whose mission is to communicate the wind turbines with the park control SCADA located in the substation control building. Wind energy offers many advantages, which explains why it's one of the fastest growing energy sources in the world. To further expand wind energy's capabilities and community benefits, researchers are working to address technical and socioeconomic challenges in support of a decarbonized electricity future. Wind power creates good-paying jobs. There are over 125,000 people working in the U.S. wind industry across all 50 states, and that number continues to grow, offering career opportunities ranging from blade fabricator to asset manager. The wind industry has the potential to support hundreds of thousands of more jobs by 2050. In 2022, wind turbines operating in all 50 states generated more than 10% of the net total of the country's energy. That same year, investments in new wind projects added $20 billion to the U.S. economy. Wind power is a clean and renewable energy source. Wind turbines harness energy from the wind using mechanical power to spin a generator and create electricity. Not only is wind an abundant and inexhaustible resource, but it also provides electricity without burning any fuel or polluting the air. Wind energy in the United States helps avoid 336 million metric tons of carbon dioxide emissions annually, equivalent to the emissions from 73 million cars. Wind power is cost-effective. Land-based, utility-scale wind turbines provide one of the lowest-priced energy sources available today. Furthermore, wind energy's cost competitiveness continues to improve with advances in the science and technology of wind energy. Meanwhile, there are also certain challenges of wind power. Wind power must compete with other low-cost energy sources. When comparing the cost of energy associated with new power plants, wind and solar projects are now more economically competitive than gas, geothermal, coal, or nuclear facilities. However, wind projects may not be cost competitive in some locations that are not windy enough. Ideal wind sites are often in remote locations. Installation challenges must be overcome to bring electricity from wind farms to urban areas where it is needed to meet demand. Upgrading the nation's transmission network to connect areas with abundant wind resources to population centers could significantly reduce the costs of expanding land-based wind energy. Turbines produce noise and alter visual aesthetics. Wind farms have different impacts on the environment compared to conventional power plants, but similar concerns exist over both the noise produced by the turbine blades and the visual impacts on the landscape. Wind plants can impact local wildlife. Although wind projects rank lower than other energy developments in terms of wildlife impacts, research is still needed to minimize wind-wildlife interactions. Pekko is a Finnish company that specializes in the design and manufacture of connection technology for concrete and steel structures. Pekko's wind turbine foundation technology is a comprehensive solution that can be tailored to the specific needs of each project. The solution includes a variety of components, such as post-tensioned anchors, dowel bars, and shear connectors, which are designed to work together to provide a strong and durable foundation for wind turbines. They provide certified and tested products like FATBAR post-tensioned anchors and PSB-headed anchors, which streamline on-site work and ensure easy maintenance. The company can provide components, design services, or a complete foundation reinforcement package, depending on the customer's needs. This flexibility allows Pekko to work with a wide range of project sizes and complexities. Another advantage of Pekko's solution is its speed and efficiency. The company has efficient production units in Europe that enable fast and reliable deliveries. Pekko's foundation solution has been used in a variety of wind energy projects around the world. The company has a strong track record of success in the Nordic market, and it is also gaining traction in other parts of the world. Rotor blades for wind turbines are a core business activity of the Magdeburg-based wind power plant manufacturer, Enercon. Highest standards of quality and dimensional stability are applied to their production, a factor which has an influence not only on the further processing and assembly of the rotor blades, but also on the efficiency of the entire wind turbine. A reliable quality control throughout the entire production process is therefore essential. Measurement of the rotor blade flanges, the sensitive interface between rotor blade and hub, is carried out with AICON's portable coordinate measuring machine MoveInspect DPA. For over 25 years, Enercon has been technology leader in the wind energy industry. Quality and innovation are the main critical success factors of Enercon's corporate strategy. A strong vertical integration and comprehensive quality management system also ensure that high-quality standards are maintained. With the mission to always deliver mature products with cutting-edge technology to customers, all Enercon system components are subjected to a continuous development process. The large staff of design engineers ensure close interdisciplinary cooperation with all company areas. Together they set technological standards for new system generations, thus strengthening the position of Enercon as Germany's market leader. Extensive simulation and test stations in the Enercon Research Center help to ensure extensive testing of new system components in the preliminary stages. Customers can therefore count on reliable system technology at the highest quality standards. The manufacture of rotor blades is carried out in different steps. Enercon's in-house engineers design wind turbines, focusing on efficiency, reliability, and adaptability to various wind conditions. They consider factors like rotor blade aerodynamics, generator technology, and control systems. Enercon manufactures rotor blades using advanced composite materials like fiberglass and carbon fiber. These materials are carefully selected and layered to optimize blade performance and durability. The nacelle houses the turbine's generator, gearbox, and control systems. Enercon manufactures these components in-house, ensuring quality control and customization. Towers can be manufactured in-house or sourced from trusted suppliers. They are typically made of steel and designed to withstand high winds and other environmental factors. Components are transported to assembly facilities, where they are assembled into complete wind turbines. This process involves precise alignment and integration of the rotor blades, nacelle, and tower. Quality control checks are conducted at various stages to ensure the turbine meets Enercon's high standards. Before shipping, wind turbines undergo rigorous testing to verify their performance and reliability. These tests may include structural load testing, aerodynamic performance testing, and electrical system testing. Enercon coordinates the transportation of wind turbines to the project site. Specialized equipment is used to transport and install the components, including cranes for lifting heavy loads. The installation process involves precise alignment and anchoring of the turbine to the foundation. Once installed, wind turbines are commissioned, which involves final checks and adjustments to ensure optimal performance. Enercon provides ongoing maintenance and support to ensure the long-term reliability and efficiency of its turbines. The flanges have a diameter of up to 3 meters. When machining the flange, the flatness of the flange must be checked directly on the machine tool. The space available for the flange measurements is about 5 by 8 meters. So far, the problem was solved with a laser tracker. For the measurement, the rotor blade had to be run back inside the machine and probed at about 100 measurement points with a handheld reflector from a ladder. Here, the biggest challenge was that exactly the same position had to be restored in order to carry out further processing steps. The measurement itself lasted well over an hour. Since the beginning of 2014, the portable coordinate measuring machine MoveInspect DPA is being successfully used at Enercon. For this particular measurement task, AICON expanded its system by a further component. A high-resolution digital camera acts in conjunction with a projector to project a point grid on the component to be measured. This allows the measurement to be made directly in the processing machine without changing the blade position. Targets are also projected, so that manual probing is not necessary.